in this problem you have four resistors and you need to find it out what is the current through one particular resistors. So this problem requires the understanding of series and parallel combination of the resistors. So take a look here. We have four resistors and the applied potential is 8 volt. Let's say the I current comes out from this one, and this is I. And this one splits into two components. It does have two paths. It can go either this way or it can go this way. And I'm assuming this is R1, R2, R3, and R4. And let's call this as an I1, 2, and let's call this as an I3, 4. Once the current is into this wire or this portion, whatever the current flows through R1 must pass through the R2. The same thing here. I3, 4 flows through R3 and R4. These two resistors are in series and these two resistors are in the parallel. I can replace these two resistors by one resistor. The same way I can replace these two resistors by the one single resistor. Now let's find out what is the combined resistance. It is just asking you through the 9 ohm resistor. So in order to find out the current through this one, what I need to know, what is the current passing through this component here. Okay, so first let's find it out what is the combined resistance of these two circuits. So R34 can be given by R3 plus R4. Why is that? Because these two are connected in series. R3 is 3 ohm plus 9, which is 12. This is R34. And now the potential, the applied potential across these two is the same as here, which is equal to the applied potential. So the potential across this one is exactly 8 volt. This is not broken, this will be a straight line. So now the current through this current can be given by, if I need to find out the current through this one, I need to know the potential and I need to know the resistance. The potential is V and the resistance is R34. The potential across this one is exactly 8 volt. So this can be given by 8 divided by 12, which is 2 divided by 3. So I34 is given by 0.67 ampere. That's the answer. Because the same current flows through R3 and the same current flows through R4. Alright? Now let's dig more. What's more now? If I ask you what is the current through R2, how do you find out the current through R2? So in order to do that, we have to find out what is R12. R12. When I say 1, 2, what does this mean? The effective resistance of 1 and 2 resistor, and these two are connected in series. So this is R1 plus R2. R1 is 2 ohm and R2 is 4. So this is given by 6 ohm. That's the effective resistance of R1 and R2. What is the potential across these two? This is exactly equal to the applied potential. So the current I12 is given by V over R12, and the applied potential is 8 volt divided by R12 is 6. So 4 divided by 3, which is given by 1.33 amp. Okay, so the current through R1 and R2 is exactly equal to 1.33 amp. The total current is now, this is I is the total current. The total current I is given by I12 plus I34, which is equal to I12 is 1.33 and I34 is 0.67, and if I add them together, what I get is 2 ampere. Okay, I can also find out the effective combined resistance. Now the entire circuit. So let me redraw this figure here. So these two resistors can be replaced by one resistor, which is R12, and these two can be replaced by one resistor, which is R34. And now you have a potential 8 volt. And again, I can replace this one by one single resistor and then apply potential. This is R1234. This one is called the combined effective resistance. So what is the effective resistance now? Let's R12 and R34 are in parallel. So R1234, what we call the R effective, is given. These two are in parallel. So if you have two resistors in parallel, the way you calculate is this way. This is a formula: R12 plus R34. Okay, what is R12? R12 is 6 ohm, R34 is 12, again the 6 plus 2, 72 divided by 18, which is 4 ohm. 4 ohm. This is 4. Alright.